Good morning. In section 7.3, we're going to talk about separable differential equations, and we're going to look at how to solve those. They call them separable equations because our goal is to separate the variables so that we can integrate both sides. So, full definition here, a separable differential equation is a first-order differential equation. Pause there. First order means that the highest differential equation the highest derivative that we'd have would be a first derivative. No second derivatives in any of these usually. So typically what happens is we have a first order differential equation that can be factored as a function of x times a function of y. So something like this. So dy dx in this case equals g of x times f of y. We call them separable because we can get the y parts together on one side and the x parts together on the other side, and having those variables separated means that we can then integrate both sides, which will look like this. For our first example, we're going to solve a separable differential equation, and then we're going to find the particular solution that goes through 0, 2. We'll switch over to the document camera to do that.
All right, for example number 1, we're going to solve this differential equation dy dx equals x squared over y squared. And then we're going to find the particular solution that goes through the point 0, 2. So to start with, I want to separate the variables. I want to get the dy and the y squared over here on this side, and I'm going to move the dx to come over here with the x squared on that side. So that's going to be y squared dy equals x squared dx. Just multiply both sides by y squared and multiplying both sides by dx. So now I can integrate both sides. And we know that the integral of y squared will be 1/3 y cubed, technically plus c. But since that's just an unknown constant, and I'm going to get another unknown constant on this other side, I'm just going to write the 1 plus c on one half of the equation instead of writing two of them. All right, so this is the general solution to the differential equation. If I wanted, I could try solving for, oops, I see a mistake. That should say cubed. I could try solving for y, but there's really not a strong need to do that in this case, I don't think. We're not asked to graph it or anything. So when graphing, sometimes it's easiest if that's y equals, but I don't think in this case it really matters. So to find the particular solution, we need to find a specific value for c. So the way we're going to do that is we're going to plug 0 in for x, 2 in for y, and then figure out what c must equal in order to keep this equation true. So this gives us 8/3 over here on the left. And then we get 0 plus c on the right, so c must be 8/3. So therefore, the particular solution to this differential equation is 1/3 y cubed equals 1/3 x cubed plus 8/3. And that would be fine. We could leave that answer. But I think one really easy simplification we could do is just multiply everything in the entire equation by 3. And that would give us y cubed equals x cubed plus 8. And then you may want both variables on one side, so maybe you'd say y cubed minus x cubed equals 8. That seems like a fairly satisfying way to write that, and that would be our solution.
For example number 2, we have another differential equation that we need to separate and solve. This time we don't have a particular solution to find, so we will be finding the general solution to this differential equation.
Here, for example number 2, we have another separable differential equation. We're going to move all of the y pieces that are here in the bottom of this fraction over to the left, and we're going to move just dx over here to the right. So this will be 2y plus cosine y dy equals 6x squared dx. So we can integrate that. And for the left-hand side, the integral of 2y is y squared. Integral of cosine y is sine of y. And again, like we said in example 1, I could put a plus c right here. But since I know I'm going to have a plus c on the right-hand side, I'm just going to do it once. I'll do it over there on the right. So the integral of 6x squared would be, 2x cubed? And that's where we'll put our plus c. So on this one, there's no particular solution to find, so we can leave c in the equation. And there's no real clear way to simplify this either. So with the AP exam coming up, I think probably the best advice I could give you is just leave it. There is no need to try to simplify this to any particular format because there's no standard form for an equation like this anyway. So this would be our solution right here.
So that's it for this section. There's not a whole lot of topics to cover. It's just one thing, solving separable differential equations. So occasionally you have to be a little creative in how you separate the variables. But in general, you're going to multiply both sides by a y piece, multiply both sides by an x piece. Sometimes divide. Sometimes you may have to divide both sides by either the x or the y. But generally speaking, that's what you're going to do. And one little tip before you get started on this homework, it's typically very smart to try to keep your dx and your dy in the top of any fractions that you might have. So you'll never see an example in our book of an integral where dy is in the bottom of a fraction, because that's just not that's not where it's supposed to be. So with that little extra tip in mind, hopefully this homework will be very within reach for you. It's just 1 through 17 odd. So on Friday, be ready if you have any questions to bring those questions to the Google Meet. And then we'll finish the week off with a quiz over sections 2 and 3 here. All right, so good luck, and let me know if you have any questions.